Lab 1, charge tapes. So in this lab, we investigated charge via transfer of electrons using strips of tape. Then we looked at the interactions between these strips of tape and other objects, and with these interactions, we determined the properties of these charged objects. And also, we revisited concepts in Physics 1, such as force and free body diagrams. And the materials for this experiment include a roll of clear tape, ruler, table, and 2 stackable objects. So some assumptions that we use for this lab regarding atoms are that they are all the same size, tightly packed, which means there's no space between atoms, and they are neatly arranged in rows and columns. And also, we treated each strip of long tape as a single point charge. So part 6, we started off by making a few U-tapes. So as you can see on the top right, that's how it's formed, and each one was 20 centimeters long. So we placed a U-tape on top of a base tape, and by ripping off the U-tape quickly, we created a charge. And I tested this charge by hanging the U-tape off of a table and putting my hand to it. And what I noticed was there was an attraction between my hand and the U-tape. So with this, I made some guesses, just saying that if 2 U-tapes are brought close together, they will repel because they're the same charge. And if a U-tape is positively charged, then it will attract to the pen, which is negatively charged. So accordingly, if the pen is negative and the U-tape is negative, then it will repel. And if a U-tape is neutral, then I think it will attract to the pen, even though the pen is negative, because the negative pen will create an induced dipole in the U-tape, thus causing an attraction. So when I actually did it, I found that 2 U-tapes repelled each other because they're the same charge. The U-tape and the pen repelled each other because they're also the same charge. And the U-tape and the wall attracted to each other. And the wall, even though it has a neutral charge, the U-tape attracted to the wall because of the induced dipole that I talked about earlier. So part 8, it involved suspending tape over 2 stackable objects and then hovering another tape below it. And with this, the net y component of force is 0 because the force of the bottom tape on the top tape is acting upwards, while the force of gravity on the top tape is acting downwards. And you can see the force diagram right there for explanation. So with the length of tape being 20 centimeters and the mass of tape being 0.2 grams, you can calculate the force of gravity and using the gravity constant, so F equals mg, and you get negative 1.96 e to the negative 3 newtons. And the separation distance, which I measured with a ruler, between the top and bottom tape were 1 centimeter, so 0.01 meters. And so with this, you could set the force of gravity equal to the force of the bottom tape on the top tape for our force diagram right here, since they're both equal. And after you rearrange the equation, you could solve for the charge of the bottom tape on the top tape, and plugging in all your values, you get 4.67 e to the negative 9 coulombs for the force for the charge of the bottom tape on the top tape. Using that charge, you divide it by the charge of an electron to get the number of electrons in excess, and then by finding the area of the surface of the tape, 20 centimeters by 2 centimeters, and you divide this by the number provided, you get the number of atoms on the surface of the tape. And by dividing the number of electrons in excess into the number of atoms on the surface of the tape, you get a ratio saying that for every 1 electron, there are 1.38 e to the 7 atoms. And so here's my code. You have your constants right here, your objects, the tape bottom, tape top as vectors, the properties of the tape, and then here are force calculations, and then finally at the end, here are the arrows that project the result up here. So the green arrow, you have the force of the bottom tape on the top tape, and the purple arrow is the force of gravity. So conclusion, if electrons were positively charged and protons negatively charged, I don't think any of my observations nor the final answers in my calculation would change. And also it's important to handle the charged tapes as little as possible because electrons may be transferred to your hand and other objects. So all in all, this experiment did a great job in reinforcing my understanding of charges and fields. That's all.